Yes. So this was the equation 6. Now that we know our integrating factor, we can just go ahead and substitute it here. We can just go ahead and substitute it here. So when we substitute it here, we are going to get E negative AT multiplied by Y all prime should be equal to E negative AT B. So when you substitute, you will get this. When you substitute, you will get this. Now let's say you don't know the equation 6, but you know the integrating factor to be this. Then it means that you don't have any equation to substitute it. So what you have to do is to just go ahead and multiply this integrating factor through. So I will multiply this integrating factor by this. So it's going to be E negative AT multiplied by Y prime, then minus, I'll also multiply it here, E negative AT A multiplied by Y, then should be equal to E negative AT multiplied by B. After doing this, focus on the left hand side. Let your focus be on the left hand side. You will notice that there is a function here. This is a function, this is also another function, this is a function, and this is also another function. You can see that Y is here and its derivative is here. Are we getting it? Y is here, its derivative is here. Therefore, if Y is this and its derivative is this, then it means that this must also be a derivative of a second function. This must be the derivative of this. Are we getting it? If this is the product rule, then it means that if y prime is the derivative of y, then it means that here too this function should be the derivative of this function. Is it making sense? Hello? Hello?
Hi, Mr. Boy.
Please, are you getting the analysis I'm making?
Yes, please. Yes.
Yes. So in that case, we can say that this whole expression becomes the product rule. So once it is the product rule, then it means that we can just pick. The concept is, now take note, the concept is, you see the integrating factor. I am going to show you a shortcut. It is always, this whole expression can be simplified. If you are simplifying, it is the integrating factor, which is E negative AT multiplied by the dependent variable, which is Y. Then you put all into brackets and find its derivative. When you simplify this, you will get this. So this whole thing can be written as this. Then that should be equal to this, which is E negative AT B. Now the reason why I am stressing on this is because it is not always that you start proving everything. Sometimes as we go on, we will get the equation. We will be able to derive the integrating factor even without going through all the steps. So once you know the integrating factor, then you only substitute it straightforward. So you have to understand this concept so that you can just find it. But when you start from the scratch and solve, you will always come across this equation 6. So when you get the integrating factor, you only substitute it inside, then you get this one. I believe you understand it.
Yes.
Okay, so now this is where we have got into this equation. We have now got into this equation, so we are supposed to solve this. Supposed to solve this one. Let me click this one. Okay, so
Please, boss.
yeah,
Peter,
hello.
your last equation, what happens to the A? Or you ignore it?
Which A?
No, there's, that place.
This
That
A.
one.
You see, that's what I'm saying. This A, it is inside here. It's here. Now let us take this one. Negative E negative AT Y. We want to differentiate this. If I want to differentiate this, I'm going to use the product rule. So the product rule says that hold the first one, which is E negative AT, and differentiate Y, you get Y prime. Then also plus hold Y and differentiate this one. When you differentiate E negative AT, you will get negative what? A. When you, because you differentiate the exponent first, so you get negative A. Then it will multiply E AT. Then you hold the Y. So look at this. Is it not the same as this one?
It's clear, thank you.
Yes, so it means that this whole thing is the same as this. Alright. So let us quickly solve it. Now we are here. We want to solve this equation. Now pay attention to this part. I'm going to do something. I want to solve this and explain something here, so let's pay attention. When you get to this point, we are supposed to integrate. So I will integrate E negative AT Y. Remember, it is a derivative, should be equal to, then I'll also integrate this one, E negative AT multiplied by B. Remember, B is a constant. Because B is a constant, I can bring the B here. It's a constant, dt. Now this integral sign will cancel the derivative here, so if it cancels, you'll be left with E negative AT Y should be equal to, if I integrate this E negative AT, I'll get negative A. I'll get negative A multiplied by B, then E negative AT plus some constant C. This is what I'll get.
I thought when you integrate, you divide rather.
Wait, let me see. Yes, it's true. Thank you, it's true. Yeah. So that's integration. So we have to divide. So we have this B over, when you integrate this one, you get So it's going to be negative b over a. Then we have e negative at. So after the integration, you add your arbitrary constant of integration. Now when you get to this point, let's bring this and this. We are bringing this one here, so it's going to be e negative at plus b over a e negative at should be equal to c. Now,
so boy,
hello.
Y is beside the
Y is
left one.
Y. Okay, yes. Thank you. So here, what I'll do is I can go ahead and solve it, but I want to explain something here. So let us, if I differentiate, now where I've gotten to this one, if I differentiate this one, pay attention, if I differentiate this whole expression and differentiate this one, what will I get? The differential, when you differentiate a constant, what will you get?
0.
You'll get 0. So
0.
yes, that's 0. So it means that this whole thing, if I introduce derivative here, this whole thing becomes 0. This whole thing becomes 0. Now this expression is called, this whole expression is called total derivative. It's called total derivative. Why is it total derivative? Because you could see that the whole function has been raised to what? Power 1. It means we are differentiating the whole function, and the rule is that the total derivative of a function is equal to 0. So always total derivative is always equal to 0. Let's take note of that. Now anytime you have a total derivative, that function we are differentiating is called the potential function. So it means that what function are we differentiating? The function inside the bracket. So this function e negative at y plus b over a e negative at is equal to c. I believe you understand that, because when you take the total derivative of it, then you get 0. So this function is called potential function, and a potential function is written in the form, is written in a functional notation. Let me write it here. So this potential function is written in the form, remember, looking at this potential function, we have the independent variable t there, and we have the dependent variable y there, and all the others are just constant. So we say that the potential function u is giving us the function of t, which is the dependent variable, then the function y of t. So this function is a potential function. Therefore, the potential function, this one is not Let me write it well so that I will distinguish it from the symbol U. So the potential function is something like this. Should be equal to, remember the potential function is always equal to C. So this is what we call the potential function. So anytime you get a potential function, it is easy to integrate it. It is always easy to integrate a potential function. It is always easy to integrate the total derivative to get a potential function. Yes, because whenever you have a total derivative and you integrate, you bring your integral sign here, bring your integral sign here. The integral sign will cancel the derivative, so you will get this. Then the the integral of 0 is a constant, so it is always easy to integrate a total derivative. That is the reason why always you have to arrange your functions in the total derivative form so that we can look for the solution to the differential equation. Alright, so let us now solve. We are now looking for the solution. So let's go back to let's focus on the potential function here. So let me write it again. E negative at y plus b over a e negative at should be equal to c. Now with this potential function, I can divide through by e exponent negative at. I'll divide through by e exponent negative at. When you divide through by e exponent negative at, you get y here, because this, when you divide through, this will cancel, then plus this becomes b over a e exponent negative at all over e exponent negative at again, so this one will also cancel, so you get b over a should be equal to, but the c becomes c over e exponent negative at, and by the laws of indices, when the e at goes up, it becomes c e exponent at. Please, do we understand up to this point?
Yes.
Alright, then we can now make y the subject. Y is a function of t, so yt is equal to c e a to the power t minus b on a, and that becomes the solution. That becomes the solution, and this is the same as what we got yesterday. That's right.